Hi everyone, Kurt with HypnoDyne again. Today we're going to take a look at the lucid dreaming functions within ZMax. I've already recorded a video about the various types of stimulation that ZMax can produce. However, today we take a look at the lucid dreaming mode. The lucid dreaming mode detects REM sleep, it detects the dream state, and when it detects that, it then triggers that stimulation that you have chosen. There are some options such as, don't bother me until 5 a.m. and don't blink the lights any faster than once every 5 minutes and whatnot. That's quite simple. The real power of this is here, it's right here, is in detection. So ZMax is now the most sophisticated lucid dreaming induction system that ever existed. Not like there were many before, but there have been a few. And I would like to review what has been done before so that you can understand the sophistication that I've built into this, so that you can appreciate how interesting this is, that this can be done now. So the first lucid dreaming induction device was called the Nova Dreamer. It came out in the 80s, thanks to the research of LaBerge and other people. And it was quite primitive. It was just an infrared LED and a photodiode. And by shining infrared light onto your eyelid and then collecting it back after it bounced off of your eyelid, it was able to detect the movement of eyes. Eyes move during REM sleep. And not only that, but they move in the same way within the dream as they're moving in your actual physical body. So if you just try to find periods of sleep in which your eyes are moving a lot, that's often REM sleep. There were some problems with the Nova Dreamer. So first of all, it's a mask, and masks tend to shift on your face throughout sleep. And the sensor really can't tell the difference between your mask moving on your face, either because of a body movement or because it came off, or because perhaps you're on your side and you're breathing. And so with that rhythmical movement, the mask is subtly moving over your face. It doesn't know. So the rate of detection and the false positives in which you were not dreaming, but it anyway went ahead and stimulated you, were substantial. Then the Nova Dreamer was taken off the market for some reason, and another device called the REM Dreamer, which does the exact same thing in the exact same way, was launched by another group. And these are devices that are quite primitive. They just use an LED and a photocoupler to detect REM sleep. Oddly enough, long after that, somebody came up with another product called the REM-E, which turns out to be even more primitive because they're not even using a photocoupler. The REM-E just tries to guess. It just sort of randomly, it's following some algorithm, but it has no physiological significance whatsoever. It just tries to send you the dream cue at random times throughout the night. So then it's a matter of luck if it actually stimulates you while you're dreaming, and then you're probably going to get stimulated while you're not dreaming as well, which is really not good for your sleep. There are other things that came out, a couple of EEG-based systems, which, a lot of what's wrong with these EEG-based systems is kind of my trade secret. It's to figure out what was wrong with them is a result of years of work into studying electrodes, studying electrode positioning, materials, the structure of sleep, phenotypes. So I don't necessarily want to go into exactly what they did wrong, but it's pretty bad. The situation is pretty bad. You don't expect any of the currently available devices to actually produce medically viable EEG signals for sleep. ZMax is thought primarily as a sleep analysis tool, so everything about it is designed and researched throughout the course of years to be able to actually acquire data that a sleep technologist or a sleep researcher can look at. What that means is that whatever patterns you're trying to detect, at the very least you know that they're there. They didn't get swamped in noise because of poor electrode material, poor positioning. So the data is there. Then, once you do capture the data, then the intelligence of the system is in the detection. There are many ways that you can try to naively detect REM sleep. And the problem with sleep is that it's not so much the classification of clean sleep, but rather the fact that sleep, as acquired with EEG amplifiers, is subject to dozens and dozens of different types of artifacts, all of which I have categorized and classified throughout the course of years. So, if you move around, the electrode signal goes out of control. Was that a rapid eye movement? Sometimes the signals are anti-correlated, just like the eye movements. And sometimes you have eyelid flutter, and sometimes you have sweat. Sweat does look a lot like huge eye movements. There's all sorts of things that can go on. So I've packed all of that complexity and all of that ability to discern not only the structure of sleep, but also all the artifacts, all the noise that's superimposed because of the nature of EEG. And I've packed that into these REM detection functions. So the REM detection in ZMax does not make generic assumptions as to the structure of sleep. And any system that does is very problematic, because it turns out that the types of patterns created by each individual person's brain during sleep are different, sometimes slightly different, sometimes dramatically different. So what ZMax does, there are two modes: night mode, which is the principal mode, and nap mode, which is a slightly modified version. So night mode is the easiest, and what it does is it waits a couple of hours, first of all, and it uses data acquired during the first couple of hours to do a quick phenotype detection, to detect what kind of sleep structure do you have and what kind of brain waves your brain is emitting throughout sleep. And based on that, after the first 2 hours, it then is able to detect REM sleep with very high specificity. That is, it only fires during REM, not in other sleep phases. Now, nap mode is an extension of that, and it's able to start stimulating right away. And you'd want this if you're trying to go for a nap, for example. You don't have 2 hours to train the algorithm as you're falling asleep. You would also use it if you don't want to keep the device on for the whole night, but you want to, for example, set the alarm at 5 a.m., put it on, and go back to sleep. It's a common technique for lucid dreaming, is wake back to bed, to wake up in the morning and go back to bed. Supposedly that's not only the time in the night where you are most likely to have lucid dreams, but also if you wake up for a while, say half an hour, pretty much optimal time, and go back to sleep, now you've sort of woken up your brain, especially the frontal lobe, but the body still thinks that it's time to sleep. So that seems to be an ideal set of conditions for lucid dreaming to occur. So if you want to do that, or just simply go for a nap, you don't have a couple of hours to analyze your phenotype, fine. All you have to do is just, do a night mode, night. That saves a file that contains information about your sleep phenotype. Then the second time, when you want to just take a nap, you load that, and it already knows who you are. It knows your specific signature of brain signals, and it can actually start detecting REM and stimulating right away. So this is the sophisticated REM detection that's occurring with ZMax. The trigger menu here is quite simple. You can decide that, although even in night mode, so after the second hour, you'd be ready to already detect REM sleep, but you might want to wait 5 hours or 7 hours. You also can tell the algorithm that if it just stimulated you, don't stimulate again for 5 minutes, because the algorithm is based on epochs. One epoch is 30 seconds. So if you put that to 0, for example, you could get this stimulation here to occur potentially every 30 seconds, which might be overkill. You can set it to whatever, 3 minutes or so. Let's put it 5 minutes. Well, once you're done with this, and no, there's not that much configuration to do. Just choose the color, and night mode is the default, and you can just go with the defaults and click OK. So the HDRecorder needs to be recording to do the REM detection. So you can click yes, and it starts recording. And you can just go to bed at this point. I don't have the device on me. It's on the table right now, but I could put it on and go to sleep, and it's going to take care of the rest. Or we stop the recording for a while. I could, and yeah, when the recording is finished, it opens the directory in which your files get saved for convenience. But you can also set the lucid dreaming mode, reply no to this dialog box. Just say don't start recording. And just for this demonstration, since I can't record the next 10 hours, I'm going to import a night that I had already saved. Okay, so this is a night that was already saved on my hard drive, and I'm going to feed it through HDScorer. First, let me turn off the device, or it's going to get confused. I'm going to feed it through as if it was recording in real time. So it's going to run the algorithm on this saved data file. And there are several reasons why that is cool and interesting that you can do that. Well, first, because I have to record this and I want to show you some stuff. So let's do it. You can see on the status that it's now reading the files. And then it's parsing them and feeding them through. These, this is called a toast notification on Android. I've created something similar. But these are actually coming from the script. There's a JavaScript script that's executed, and you don't need to look at it, you don't need to know it exists, you don't have to worry about it at all, but just in case you like to try different things, there's actually a script that gets called every time a REM epoch is detected. So if you wanted to go well beyond what the algorithm is able to do in terms of stimulation, from that JavaScript you can do all sorts of things. You can play a sound, perhaps with some sound suggestions, try to get into some kind of dream state, or you could operate any type of USB peripheral. So like if you have stuff that you want to turn on, like a fan or some light, you could do that. Anyway, just forget about that for a second. The important thing here is just the phenotype, right, that got detected. Would you like to save the results of the phenotype? In this case, I clicked no because I've already saved it a bunch of times. But yeah, it's telling me that the operation was successful and that my files got saved. So I open HDScorer now. I'll show you why. Again, I open an existing set of data files, but the point is to simulate the acquisition of a whole night of data. So let's suppose that I just woke up and this is my night of data, and I just load it into HDScorer. And so this is what my brain produced throughout the course of a night, let's say. The interesting thing here is import markers. These got created by HDScorer. So let me explain what it did. It took in this signal, which was pre-existing, but we're simulating acquiring it directly from the ZMax throughout the night. Then it ran the night through the REM detection algorithm, and it output a set of markers shown here in pink on black that contain some information. And for example, here it's telling me REM detection and stimulation. I go to the next one. REM detection, but it doesn't say stimulation. That's because I told it that it didn't want to be stimulated more than once every 5 minutes. So it ignored this REM detection. Go to the next one. That's also ignored. Next one. Okay, now 5 minutes have elapsed since the first one, so again, it's stimulated. and so on and so forth. Okay, so you have two types of markers, either just detection or detection and stimulation. And you will notice that it was able to pick the REM periods very, very accurately. There's no false positives. Let's look at these epochs. You see, these are eye movements. Go to the next one. These also nice eye movements here, and so on and so forth. These are all good eye movements. It's calibrated for specificity as opposed to sensitivity. And what that means is that it's perfectly happy to ignore some eye movements some of the time, as long as it doesn't misclassify and stimulate when it shouldn't. So, you know, if I were to score this, most likely all of this would all be REM sleep. But it only found a few points, because these are the points that are the least controversial. Not only that, but look, there's a N2 epoch right near that. Is that what it is? Is that N2? You know what's happening here, I think, is that this is a K complex. It's a characteristic of N2 sleep. And so this sleep is a little bit odd. This is my sleep, right? You can see here, for example, so I happen to be a beta wave producer during REM. That's interesting. I haven't seen anyone else produce so much beta activity during REM. You can see from this band right here. Most other people don't have this. And if you look at this first, I would call it a botched attempt at REM, because it seems like I'm going into REM and coming back to N2 like really quickly. If we analyze this, there's some eye movements there, and there's an arousal, and then there's N2 activity, and then some more K complexes, eye movements. See, this is a K complex, N2, the very next epoch, again, eye movements. And you can see it, right? How do you see it? Well, this is the spindle frequency. You can go and review my older video about how to score a sleep and the spectrogram. It talks about these horizontal ridges. These are the spindles that occur during slow wave sleep. And because I'm seeing that the beta activity that occurs during my REM sleep is overlapped onto the spindle frequency, but both are kind of weak and coming and going, then I know that this is a period in which I guess my brain didn't really know what it wanted to do. It kind of wanted to stay asleep, but it also wanted to do a little bit of dreaming. And so this is quite confused. So that's why the algorithm didn't score that. Oh, forget that, sorry. This is not 2 hours yet, so that's why I got ignored. Okay, fine. But here, this is solid REM sleep. You see the sleep spindles are disappearing completely. Well, almost completely, right? There's still a little bit in between. Like, I guess this is a little dot that could constitute, yeah, N2 activity. It's mixed, but not as very strongly mixed as before. But this is interesting now, right? Because you have the algorithm running here, and you can go to sleep at night, and you can wake up in the morning, look at what your sleep structure looked like, and also you can know where the algorithm decided, hey, that's REM sleep. This guy's dreaming. You can go and verify that. You can verify that stimulation actually occurred. You can verify where the stimulation happened so that you know, hey, right here, it did stimulate me. You can look at the results of the stimulation. Like there's some experiments that got done in the 80s where people who were experienced lucid dreamers, they learned a routine where if they were in a dream and they realized it was a dream, okay, I'm lucid dreaming, then they did a particular sequence of eye movements with which they could communicate with the researchers. As I said before, the movements of the dream eyes, if you look left and right in a dream, those movements are exactly the same as your real eyes in your physical body. So whatever pattern of eye movements you do within a dream, that actually shows up here on the recording, and you can see it. So you can run your own experiments of this kind where you're able to signal that, yes, I achieve lucidity. You can, for example, do a set of, I don't know, 20 very regular eye movements, left, right, because the eye movements in normal sleep, they're very random. Sometimes they're small, sometimes they're big, sometimes they're large, sometimes they're very fast. It really depends on what you're seeing in the dream and how you're directing your gaze. But you can control that voluntarily within the dream. And so you could communicate back to yourself like this, just like they demonstrated in the 80s. And you could even, look at the epoch and say, hey, that's the stimulation right here, and in the very next epoch, I became lucid, and look, that's my dream signal that I was actually lucid during that time. And that's very cool stuff because there's not much funding for dream research, and so the stuff that they were able to do in the 80s, no one's doing it right now. It hasn't been done since. There's even an idea that I had a while ago about using Morse code. They were able in the 80s to use Morse code to further validate that the person had control over the eye movements. The person was able to spell his first and last initial, the initials, obviously, of the first and last name with eye movements in Morse code. So if somebody's really good at it and they become lucid very often and they're able to control their eye movements, which I think most people would, then I don't exclude the ability to use eye movements to then trigger stimulation, which then you could, within the dream, move your eyes, tell the machine to stimulate you as you're dreaming, and then observe the result of the stimulation within the dream. And if you're really good, you can even send me an email. Okay, so very interesting stuff, right? So it's the first system that actually allows you to see the raw data, to see the detection, and to see the results of the stimulation. Hasn't been done before. There's a big difference between systems that claim to help you to achieve lucidity, but they're not showing you the data. There's no way to check, are they working or not? Did they stimulate me or not? There's such a thing as a placebo effect too, If you think, oh, I'm going to use this thing for lucid dreaming, to some extent that works as well, even if the machine is doing nothing. So it's very good that now there's a system where not only a researcher, but a consumer can look at their sleep structure, experiment with lucid dreaming. There's a bunch of, as I was mentioning before, this thing is scriptable, right? So I'm going to actually show you what the script looks like. I open in Notepad. So here we have a script, and if you're not a programmer, then please ignore all of this, don't get freaked out. But basically every time that an epoch is acquired, that is 30 seconds of sleep, this function in your little JavaScript file is called by HDRecorder. And one of the parameters that it gets back from HDRecorder is this is_REM, which tells you if you're in REM sleep. So you can do a bunch of things in response to REM, which go beyond the stimulation capabilities offered by HDRecorder. This is useful if you want to do your research, or if you want to try different things. Like, for example, there's a function for speech synthesis. So you could have your PC say things to you as you're asleep. You could also pre-record what you want it to say and then play it back, or whatever sound file, sound effects, and try that way to influence the content of your dreams. There are other things that you could do. For example, if you're having frequent nightmares or night terrors, you could monitor the heart rate, which you can get with this one, ZMax Get BPM. This gives you the heart rate. So what you could do is compare this heart rate with a maximum threshold, say 110 beats per minute, or even less. My heart rate during wake is probably about like 58, 60 BPM. During sleep, it's often less than that. But let's say it exceeds 100, then you're nearly sure that you're not in a good state. Either you're having a nightmare or there's a night terror. So in response to that, you could then, I don't know, play a sound, like a really loud sound that wakes you up. There are other functions, but I didn't want to necessarily go into the scripting now because I'm still developing it. So there will be a very complete tutorial later. Oh yeah, one thing to mention. So I actually played around and created a function using only JavaScript just to demonstrate scripting. And what this does, well, button 1 is a function that's called whenever you push the left button on ZMax. And you can program it to do whatever you want. Like you can, push the button, it can play a sound for you. What I've programmed it to do using only JavaScript is to record an audio file. So this is the can't recall. It's a voice dream log function that I was, well, I have on the website, and I probably mentioned it before in reference to the MP3 Dream Logger software, which now is not needed anymore because you can do the same thing in ZMax. So let's see how that works. Let me start over here. I'm going to go to quick start. Okay, so we're streaming data. And what I do is push the left button on ZMax, which I have here in my hands, but it could be on my forehead, right? So it's very easy. There's only 3 buttons, so I can find the left one with my finger, and I push it.
Voice recording started.
Hello, this is the voice recording. I'm recording the content of the dream without opening my eyes so that I can go back to sleep. And this is my dream log to help me to remember my dreams. Okay, then I click the left button again.
Voice recording completed.
And that just got magically stored under entries. There you go, MP3 file. I don't know if I can play it because I'm recording from the screen. Yeah, probably not, because I'm using a screen recording software.
This is the voice
yeah, okay, it's working.
I'm recording the content of the dream without opening my eyes so that I can go back to sleep.
So this is extremely useful because, you know, you have to record your dream content if you want to experiment with dreaming and lucid dreaming. Otherwise, you won't remember your dreams. And then if you don't remember them, then it's all for nothing. So this allows you to do that without waking up, turning on the light, and finding a pen and all of that.